All right, this is the review for the Unit 7 Rational Functions test, and this is going to be part 2, so we're starting at number 13 on the review. It says solve for x in the equation below. All right, since this is one fraction on the left and one fraction on the right, then we can cross multiply. So we're going to multiply x minus 3 times x plus 6. And then that will equal, we'll cross multiply the others, x minus 8 times x plus 3. Okay, then to multiply these together, we use FOIL. Okay, so we're going to multiply x times x would be x squared. And then we have the inside terms, which is negative 3x, and the outside terms, which is positive 6x. Negative 3x and positive 6x is positive 3x. Then negative 3 times 6 is negative 18. Okay, then we'll FOIL the other side. X times x is x squared. And then 3x minus 8x is a negative 5x. Then negative 8 times 3 is negative 24. All right, since we've got x squared, we can subtract x squared from both sides. And x squared minus x squared cancels, and that one cancels, and we get 3x minus 18 equals negative 5x minus 24. We're going to get all the x's on one side, numbers on the other, so we'll add 5x to both sides. That gives us 8x minus 18, and those cancel, and that equals negative 24. Then we'll add 18 to both sides. So 8x equals negative 6. Then divide by 8, and x equals, and this can be reduced to negative 3/4. And that would be h. Okay, we would want to check the restrictions. The restrictions on here would be x cannot equal 8, because if I plug 8 in here, 8 minus 8 is 0. We can't divide by 0. And it can't be negative 6, so that would give me 0 over here in that denominator. Okay, and so negative 3/4 is not 0 or negative 6, so it can be an answer. All right, number 14. What are the domain restrictions, if any, on the domain of the following equation? So we're finding the domain restrictions. We're going to go ahead and factor. So x squared minus 25 would be x minus 5 times x plus 5. And on the bottom, we would have x times x, and 6 times 1. Actually, it's going to be 3 times 2, which is 6. And they'll both be plus. That way, when you add them, you get 3x and 2x, which is a positive 5x. And when you multiply them, you get 3 times 2, which is 6. Okay, nothing cancels out, so we're going to take the denominator and set it equal to 0. So we're going to set x plus 3 equal to 0 and x plus 2 equal to 0. So x equals negative 3 and x equals negative 2, which means our restrictions are x cannot equal negative 3 or negative 2. Because if we plug in negative 3, we're going to get a 0, or if we plug in negative 2, we're going to get a 0. So those would be your restrictions on the domain. Okay, number 15. What is a reasonable domain and range for this scenario? It says water is added to a 60 milliliter solution that is 50% acid. The equation a of x equals 30 over 60 plus x represents the concentration of acid A in the mixtures as x amount of water added. So A is the concentration of the acid, and x is the amount of water added. Okay, okay, so let's look at x. We're going to see what x can be. So x is the amount of water added. Can't add negative amount of water, so x cannot be negative. We could add 0 amount of water, and we could add anything above 0, like 1, 2, 3, or 50 milliliters, or 1,000 milliliters. Okay, so we're going to say that the domain is x can be anything greater than or equal to 0. Then for the range, The range is Y. In this case, the range is an A here. Okay, so we know that if we add 0 amount of water, we have 30 over 60, because 0 plus 60 is 60, which is a half, which is equal to 50%. Then if we start adding more and more water, what's going to happen is we have this 50% solution that's going to be diluted, and it won't be 50% acid anymore. It'll be less and less percent acid. Okay, so if we add like 10, then we'll have 30 over 70, which is 3/7, which is less than a half, which is less than 50%. So it'll keep going down, and the more water we add, the less concentration of acid we have. So the percent will keep going down and down and down, and it will never reach 0 because we'll always have some acid in there. Even if we add 1,000 milliliters or 10,000 milliliters of water, we'll still have a little bit of acid in there. So it'll get closer and closer to 0, but never reach it. So A can be, and you could use Y here and that would be fine too, but it can be anything greater than 0, but it can't equal 0. It will never reach 0. And I said that, I put that backwards. A can be greater than 0, or A can be less than or equal to 50%, or you could put 1/2 here because that's the same thing as 50%. Okay, so that would be your domain and range. It could never go above 50% because we can't take water away from here. That would be the only way to get it above 50%. Okay, 16. Scott and Ian design a cool t-shirt for skateboarders. Their friends are very impressed and everybody wants one. So Scott and Ian set up a t-shirt printing business in their garage. The total startup costs are $450 due to availability of a graphics machine. They estimate that it costs $550 to print each t-shirt. Write a rational function A of X, giving the cost per shirt of producing X t-shirts. Okay, so we want to know how much it costs to produce every shirt, how much it costs per shirt. And it says use A of X as your function, so A of X equals, and how much does it cost to print the t-shirts? Well, it costs $450 as a startup cost, plus $5.50 for each shirt. So we'll let X equal the shirts. Okay, so $450 plus $5.50 times X would be how much it costs to print all the shirts. And then if you want to know how much it costs per shirt, then you would divide by the number of shirts. And this would be your answer. All right, now this one's very similar. This next one, number 17. Eco Publishing spent $5,000 to produce an environmental handbook and $7 each for printing. If X represents the number of handbooks printed, the following function shows the average cost to the company per printed handbook. Okay, so see how very similar this one is? This is saying that it costs $5,000 to produce the handbook and then $7 for each one to print it. And then you divide by the number of handbooks to see how much it costs to print each handbook. Now the question is, what happens to the average cost of the handbook as more are printed? So the more you print, let's say we print 25, what's going to happen to the cost of the handbook? Well, the more that they make or print, the less that it's going to cost because you're dividing by a bigger number down here. Okay, and if it decreases, does it approach 0 or does it approach 7? Okay, you want to look at, you want to think about 0, would it ever cost nothing to print the handbooks? No, it's going to cost at least $7 a handbook. All right, so you know it's not C, it's got to be D. And another thing to look at to see if it's approaching 7 is the horizontal asymptote. Okay, because these have the same exponent, they're both x's, we look at their coefficients. Coefficient in front of this one is a 1. So we do 7 divided by 1, which is 7. So y approaches 7. So that's why we get 7 down Okay, then number 18, we're going to solve by graphing. We've got x plus 2 divided by x minus 1 equals 2. All right, to solve by graphing, we're just going to put it in our calculator. Okay, and we're going to say put in y equals. So y1 is this one and y2 is this one. Okay, so in y1, we're going to put parentheses, x plus 2 divided by parentheses, x minus 1. And then in y2 we'll put 2, and then we're going to find where they intersect, and that's going to be our solution. And we're going to sketch it. So I'm going to do zoom 6. Okay, the line going across at 2 is this part of the equation. So I'm going to sketch a line going across at 2. Okay, and that looks like there's an asymptote around 1, which would make sense, because if you set it equals 0, you get 1. Okay, then it looks like it crosses at 4, so I'm going to go ahead and kind of let it sketch it so that it crosses at 4, and then we're going to double check that. Okay, then over here this comes down like this. All right, to find the intersection, we're going to do second, trace, intersect. Okay, then I'm going to enter on first curve, enter on second curve, and then on guess, I need to move my cursor over to where they intersect, and push enter. Okay, and we get 4, x equals 4. So the answer is x equals 4, and they intersect at 4. Okay, if you don't do it by graphing, then you would do x plus 2 over x minus 1 equals 2. And to solve it, we can put a 1 under here, and then we can cross multiply. So we would have 2 times x minus 1, which would be 2x minus 2, equals 1 times x plus 2, which would be x plus 2. Okay, then subtract x from both sides. We get 1x minus 2 equals 2. Then add 2, and x equals 4. Same thing. Okay, you just want to make sure that it doesn't conflict with any restrictions. So if you look here, and the only restriction that would be here is 1, because that would be what would make the denominator 0. So you can say x can only equal 1. But we got 4, so we're good. We got it by graphing. We did it by an intersection on the graph. We also did it algebraically. You only have to do it one way on the test. You don't have to do it both ways. All right, that would be it.